Alright, welcome to our elective maths class. Today we're looking at calculus as a branch of mathematics or as a field or area of mathematics. The study of calculus as a math student is very essential. Therefore, there is the need for you to take time and then study it carefully. So calculus seeks to expose the student to the study of limits, differentiation, and integration. Where under differentiation you'll be looking at the notations. So under calculus will expose you to differentials or differentiation. Then integration or integrals, and then limits of functions. Limits or lim. Very good. So calculus, you'll be studying differentiation, integration, and limits of function. Under differentiation, you'll be looking at notations. That is differentials. We'll be looking at the first principle. We also look at the product rule. From product rule, then you go to quotient rule. Then you also look at that is product rule, function of what? Functions. Very good. So product rule, quotient rule, and then function of functions, and under integrals, we're looking at U substitution. We also use integrals. We'll be looking at integrals. Then integration by parts. Integration by parts, and then we look at its application. That is using the knowledge that we have in differentiation and integration to find problems to life-related issues. So after that, we will look at limit of functions. Limit of function. So under this topic, we'll be looking at differentiation, integration, and limits, as I said. So now let's start with differentiation. Okay, so differentiation. Let's look at this function x exponent 3. Whenever you are being asked to differentiate this term, what does it mean? Let us establish the concept of differentiation. Now, under differentiation, what you do is that you multiply the exponent of the term by the coefficient of the term. After that, you subtract 1 from the exponent. So the coefficient of this term is 1. So you first multiply the exponent by the coefficient. So 3 times 1 will give you 3. Then you write the term, or let's say the variable x. Then you subtract 1 from the exponent. So if you take 1 from 3, it will give you 2. So if you differentiate x exponent 3, you will get 3x squared. Now, let's go to x exponent 4. Multiply the exponent by the coefficient. So we have 4 here. Write the term, that is x. You subtract 1 from the exponent, so this one will give us exponent 3. X exponent 5. If you are being asked to differentiate this term, you first multiply, as I said, the exponent by the coefficient of this term, that is 5. You write the variable there, x. Then you subtract 1 from the exponent. So if you take 1 from 5, it will give you 4. So in general, Let's say that you have x exponent a. Let's look at the general term for differentiating a function or a term. In general, if you have s exponent a, or let me say s exponent n, what you do is that you multiply the exponent of x by the coefficient of x. So x times the coefficient of x, you get your n here. Then you write your x, then n minus 1. So in general, that is a generic idea or concept of differentiating a term. As we move forward, or as we dive deep into our lesson, we'll be using this concept. So try to understand basically how to differentiate a term. So I said that you multiply the exponent by the coefficient, then you take 1 from the exponent. Let's look at this example. If you have 2x exponent 4, you have been asked to differentiate this. If you have been asked to differentiate this, as I said, multiply the exponent, that is 4, by the 2. Whatever value in front of the variable here, multiply it. So 4 times 2 will give you 8. Then you write your x. What will you do to the exponent? Take 1 from it. So this one will become exponent 3. That is what we call you are differentiating with respect to the variable under question. Okay. Okay. So let's say that we have a function y is equal to s cubed plus 4x exponent 2. You have been asked to find the derivative. Find the derivative or derivate of y, or the function, or differentiate y is equal to s cubed plus 4s squared. What it means is that the derivative is denoted as d. So you are differentiating y, so dy, with respect to x. So you are dy dx. Dy dx means that you are differentiating this function with respect to what? X. Meaning that in your final answer or in your differentiation, what you expect is that the function you are differentiating y, this y, with respect to what? To x. This will be equal to s cubed. Let's differentiate it. So s cubed, how do we differentiate s cubed? We multiply the exponent by the coefficient. So we have 3. And you write here x. You take 1 from the coefficient of x. So 1 from 3 will give us 2. Bring the operation sign, plus 4s squared. Let's differentiate this as a single term. So 2 times the 4 will give us 8. Then we have x. If you take 1 from 2, it's 1. By a number exponent 1 is the same number. So that is that. Your final answer. So simple. So that is how you go by differentiation. You should take note. Now let's look at something here. Differentiation of a constant. Now, let's say that in the course of you differentiating a function, you will come into contact with a constant number. Let's say 5. If you differentiate a constant, what are you going to get? Let's look at something here. Whenever you see 5 as a single digit or as a constant, what you have to bear in mind is that if you are to apply the idea or the concept of indices over here, under indices we said that a number exponent 0, let's say s exponent 0 is the same as 1. So if s exponent 0 is the same as 1, and 1 times a number is the same number, we can say that 5 times 1 is the same as 5. So when you see 5, you have to bear in mind that there is a certain one multiplying this 5. The 1 is silent. So 5 times 1 is the same as 5. When you see 2 there, remember that there is 1 as an identity number multiplying the 2. You should bear in mind. So this 5 that you see has what we call a certain one multiplying the 5, but it is silent. It doesn't appear in the equation for you to see. It is hidden. So if you have eyes, you can see. Okay, so 5 times 1 is the same as 5. A number exponent 0 is the same as 1. So y exponent 0 is the same as 1. So now we can substitute x exponent 0 in place of 1. So 5 times, let's say, y exponent 0. Y exponent 0 is 1. So 5 times y exponent 0 will give us 5y exponent 0. Now let's differentiate this. If you are being asked to differentiate this, you multiply the exponent of the unknown variable, that is 0 times 5. So 0 times 5 will give us 0 here. Then you write your y. Don't forget, it is multiplication. So sometimes in mathematics, dot means times. When you go to scalar quantities or dot product, you will understand, or be using dot as a multiplication sign. So take you. So 0 times y minus 1, so exponent negative 1. And don't forget, 0 times y is negative 1 is 0. So any number times 0 is 0. That means that if you differentiate a constant, is 1. Take note. Alright, so that is the proof of differentiating a constant and getting 0. Okay, now let's look at differentiating. If you have 5x, let's see what you get. If you are being asked to differentiate this term, don't forget that x is exponent 1. So 1 times 5 will give you 5. Then you have x exponent 1 minus 1. 1 minus 1 will give us 0. X exponent 0 is 1. So we have 5 times 1. 1 times 5 will give us 5. So whenever you are differentiating a term of this kind, or a number exponent 1, is the same as the coefficient of the term. So you should take notice of that. So basically, that is the idea of differentiation under calculus. You'll be using the first principle to arrive at the same answer. In other words, I will say that the notation is the shortest or the simplest way that you can ever use to differentiate a function. Now, let's look at the first principle. Okay, so the first principle, as I will say, is another method or a way or a mechanism that you can use to differentiate a function, or you can use to differentiate a term. But because it is a principle, let's look at the principle. But before we even state the principle down, let's look at how the principle was generated. As I said earlier on, differentiation, we're looking at determining the steepness or the slope of a line or a curve. So sometimes, as much as we are learning this concept, you'll be equating the differential of a function as the gradient of a function. So let's look at the first principle. Look, seeing the Cartesian plane. So let's draw our Cartesian plane. So we have our x, we have our y, we have our negative x, our negative y, representing the inverse of the positive two axes. So as usual, the point of intersection still remains our 0. Now, let's say that there is a point on the curve here, or there is a point on the Cartesian plane. Let's make this S0. This is Y0. How do we get the coordinates? Let me bring this point down. This is point A. How do we get the coordinate of point A? You step at point A and you move towards the x-axis. Then you step at point A and you move towards the y-axis. Because every coordinate has what you call the x and y coordinate of that point. So you step at point A, you move towards x. So the whole of this line is called S0. So let's say that from the point of origin to this point is x. Then from point A you move towards y. So you can say that this is y. But don't forget, during our study of functions, we said that y is the same as f of x. So f of x is the same as y. So now let's make use of what? The f of x instead of our y. So over here we write f of x. So our coordinate becomes x and f of x, where x is the x coordinate of point A and f of x is the y coordinate of point A. Okay. Now, let's say there is another point B. I didn't want to draw the curve before I generate the point. So let's start from this way. It will be very helpful. So as we did the same thing, to get the coordinates of point B, you start at point B, then you move towards the x and y axis of the Cartesian plane. So now, let's say that from the point of origin to point A is x. So this x is not just a point here, but from here to here is x. Now, let's say from point A to, let's say point C. Let's denote it by h, just any variable is h. So we have our point C here, point C here. So how do we get the total distance of point C? Let's do some kg mass over here. 0, 1, 2, 3. Kofi, Amakrum. We are saying that before you can move from Amakrum to Kofi Krum, or if Ama happens to be Kofi's fiancé, and Ama wants to go and see Kofi, it means that Ama have to make 3 moves. So 1, 2, and 3. Don't forget, from this point 0 to this point is 2. From this point where Ama is, the point of origin, to let's say point X is 2. And the ending point is what? 3. Let me clean the 2 and let's do some simple calculation here. If from point 0, that is where Ama is, to point K is 1, and point K to where Kofi is, we don't know, but then the ending point is 3. How do we get the distance of this place? So if you take 1 from 3, you get this side to be 2. So the 3 that you see here is the sum of 1 and 2. So the sum of 1 and 2 will give you the 3 over here. Let's apply that idea over here. What I'm trying to say is that this point C is the sum of x and h. X plus h will give you c. So point C on the x-axis will have the value of x plus h. Take note. So the x coordinate of point B is x plus h. Okay. Now, what about the y coordinate of point B? It's just finding the f of the s coordinate of point B. So let's go. So this will be f of s plus h as one side. Now we can join the 2 points together. You see that there is a curve here. So like AB. And you are being asked to find the gradient of this curve. If you are being asked to find the gradient of this curve, we all know that gradient is equal to a change in your y values on the change in x values. Or in other words, the projection of line AB on the y axis against the projection of line AB on the x axis. That is for gradient. So let's apply the concept over here. We said that gradient M will be equal to projection of this line or this curve on the y axis. So let's say delta y on delta x. This delta y, this symbol is pronounced delta y, representing change. Change is the same as y2 minus y1 on s2 minus s1. Don't forget, we said that gradient of the curve is the same as dy ds, or the same as limit as, let's say, h approaches 0, or the f prime of x. That is, if you differentiate f of x, you write it as f prime of x. So now we can substitute dy dx, and this is the same as your gradient. So this gradient M that we see here, you can substitute dy dx. You can substitute length as h approaches 0 or infinite function or f prime of x. You can substitute any of them depending on the variables that you are using. Don't forget. So now let's continue with our calculation. y2. So you have f of x plus h. Good. So point A, you have x1, y1. You have x2, y2. So let's find the gradient of line AB. So gradient of line AB, you have point A. Point A, we have x and f of x. Then point B, we have x plus h against f of s plus h. So we have to find the gradient of the line passing through the point A, B. We have already established that gradient M will be equal to change in the y values against the change in x values. So now let's go with the limit function. So limit as h approaches 0, your gradient function will be equal to y2. So we have x1, y1, s2, y2. y2 is f of s plus h. So you write f of x plus h minus y1. y1 is f of s. We are just doing substitution. We are just keying in the coordinate into the gradient function. So this will go to f of x divided by, let's come back, s2 minus x1. Then you ask yourself, where is your s2? And where is your x1? This is our s2, s plus h minus x1 minus x. So now we have our dx, which is equal to f of x plus h minus f of x divided by, don't forget, the coefficient of this term is 1. So you multiply 1 by x, you get x. 1 by h, you get plus h. Then minus x. Positive x, negative x will give you neutral. If you multiply the neutral by h, you still get the h. So our gradient now is equal to f of x plus h minus f of x. On this negative s, will do away with the positive s. I don't want to do cancellation over here. Please take note. Sometimes after examination, the students will come out boasting. As for these people, they have written everything. But there are some mistakes that sometimes students do unconsciously. We are saying that maths, if you want to divide something, if you want to do away with something, don't cancel anything. Just move ahead with the correct value in your step. So x will do away with this x, leaving us h. Or better still, if you want to cancel, do away. So our gradient L is equal to f of s plus h minus f of s, all on h. And as I said, these values are the same. You can equate. So now we say that limit as h approaches 0, your gradient is being given as f of x plus h minus f of x on h. So this is what we call differentiating from the first principle. Very good. So use this formula, or if you use this idea to find the derivative of a function, then we say that you are differentiating that function with respect to what? Yes. So if you use this, then you are saying that you are using the first principle. So now let's use the first principle to find the derivative of a function. So take note, that is the first principle, and that is the proof of the first principle. Alright, so we have to differentiate s squared using the first principle. Whenever you are being asked this type of question, I believe that once you have been limited to use the first principle, you have no option than to use the first principle. I know that there are other ways that you can use to differentiate s squared, but you have no option. You have been limited to use the first principle. So please, if you want to get the correct mass for this question, then let's use the first principle. And what is the first principle? It says that limit as h approaches 0, f of s plus h minus f of s divided by h will give you the gradient of the line passing through this term or equation. Very good. So now, without even using the first principle, or before you use the first principle to get the answer of this question, let's write the answer there, or let's predict our answer. If you differentiate s squared, what will you get? You will get 2x. 2 times the coefficient will give you 2. Then x minus 1 will give you 2x. So after using the first principle, you should get 2s as the answer. Anything apart from 2s will equally put you into J. Okay. So now, solution. What is the first principle? It says that your limit function as h approaches 0 is equal to f of x plus h minus f of x all divided by h. It's very simple. So we have two sides of the equation. You are not going to use the left side. So let's consider the right side. So we are coming to consider the right side of the equation to differentiate. So f of s plus h. Don't forget, the coefficient of s squared is f. So we are rewriting this term. We are rewriting what? X. So f of x squared. F, the coefficient of s squared is 1. So the f is 1. And 1 is a neutral number. You can choose to write, you can choose not to write. So the coefficient of this is 1. So let's write 1. Then f of x. So s squared, we get our s plus h squared. We are done with the first part. We are rewriting the term. So we have s squared. So it is the coefficient of this is f. So 1x plus h. Then you bring minus f of x is the same. Let's say y is equal to f of x. F of s is the function. F of s is the function. So you just write s squared there. You write your s squared all divided by h. So now we have s plus h, s1 and 2, minus s squared all on h. Let's expand this. If you expand this, you get s squared plus 2x h plus h squared. As elective math student or someone who have studied elective math from Form 1, Form 2, up to your final year, it is expected that expanding this binomial term is not a new thing to you. So we don't want to waste time to explain this expansion. So let's continue. So the whole of x plus h exponent 2 will give us s squared plus 2sh plus h squared minus s squared. So minus s squared all divided by h. Once again, we have s squared, we have negative s squared. So this will cancel this, leaving us 2sh plus h squared all on h. Lim as h approaches 0. Lim as h approaches 0. Lim as h approaches 0. Okay, so now let's do some indices over here. Limit as h approaches 0. 2sh. This h is affecting the first term at the same time the second term. So 2xh divided by h plus h squared divided by h. This h will cancel this h. This h is exponent 1. So the laws of indices, if you have the same base, dividing, you subtract, or you find the difference between the exponent. So this goes into this 1h. So now we have lim as h approaches 0. This will go to 2x plus. So we have minus over here. So the minus is gone. So we have plus h. So now, if you substitute h is equal to 0 into this function, the function will be defined. But let's say that when we got here, then we put h is equal to 0. The function will be undefined. So at this point, you have to continue to expatiate or expand or disintegrate the function. You have to decompose the function, break it down to the level that when you substitute h is equal to 0 into the function, the whole of this function will not be undefined. So we have h. So over here, you can substitute h is equal to 0. So our gradient function will be equal to 2x plus 0. Somebody may ask, where from the 0? The 0 is the value for what? H. So 0 plus 2x is the same as what? 2x. Now have you seen that we've gotten 2x for s squared? So that is how you differentiate from the first principle. Okay, so we have to find the derivative of 4s squared plus 2x from the first principle. Solution. So the first principle says that lim as h approaches 0, lim, L-I-M, that is limit of the function as h approaches 0 is equal to f of x plus h minus f of x on h. So lim as h approaches 0. Let's rewrite the function again. So we are writing this function. So 4, write the 4. S, don't write x, but when you see x, you write x plus h. So we have x plus h. There is a square up there, bring it. Square plus 2x. What is x? Wherever you see x, bring s plus h minus, that is the operational sign, minus. I prefer to use the minus f of x, and f of x is 4s squared plus 2x. 4s squared plus 2x. All divided by h. All divided by h. So now let's expand the bracket. Let's expand the bracket. Come to this side with me. So lim as h approaches 0, we have 4. That is the coefficient of the term. Let's maintain it. If you expand s plus h squared using the part, you can use Pascal's triangle, you can use the combination method, or even the binomial expansion, or even the normal factorization method. You can use to solve it. So x plus h, x plus h, x plus h. So s times x will give you s squared. S times h will give you xh. H times s will give you sh. Plus h times h will give you h squared. So you can see that we have 2 of sh here. So s squared plus sh plus h squared. So now we are coming to substitute s squared plus h, sh plus h squared into the equation. So s squared plus 2sh plus h squared minus, what is there? Sorry, we have plus 2. Let's expand this bracket. 2 times s will give you 2x. So write it there. 2 times h will give you 2h. So plus 2h. We are coming to use the whole board. As in 1/3 minus 4s squared plus 2x. Don't forget. This one is in brackets, so you have to put it in the bracket. So let's put this into bracket. It's very necessary. So let's expand this. Lim as h approaches 0 will be equal to 4 times s squared will give you 4s squared. 4 times 2sh will give you plus 8xh plus 4 times h squared will give you 4h squared. Let's come to this side. We have plus 2x. We have plus 2h. Then negative 4x squared. This negative 1 will times the 4s squared. So we get negative 4s squared. Negative 2x. Okay, so then when you reach this level, some neutralization or cancellation. Negative 4s squared will cancel positive 4s squared. Negative 2s will neutralize with positive 2s. So now we have limit as h approaches 0. 8xh plus 4h squared plus 2h all divided by h. Good. So we have our limits. Our limit as h approaches 0. This h is affecting 8sh. So we write 8sh over h plus 4h squared on h. So 4h squared on h plus 2h on h. So I think we can do some cancellation here. H goes into 8sh, 8s. H goes into 4h squared, 4h. Then this h will do away with this h. So our expression now becomes limit as h approaches 0. Then you write this is equal to 8x plus 4h plus 2. Then at this level you can do direct substitution. You can substitute 0 into it. So our expression now becomes 8x plus 4h, you write 0. So 0 plus 2. 4 times 0 is 0. So 8x plus 2. So limit as h approaches 0 or the derivative using the first principle you get 8x plus 2 as the final answer. Now let's look at something here. Let's differentiate 4s squared plus 2s. Let's use the shortcut to see if you get 8s plus 2. If you differentiate 4s squared, so 2 times 4 8, then x minus 1, so x plus 2x. Exponent 1 is 1 times 2, 2. X minus 1, so exponent 0, so you get 8x plus 2. So that is that for the first principle. So we've already established the basis of differentiation, and you have solved questions or questions for differentiating using the first principle. Please make sure you solve questions using the first principle. So let me leave you with this exercise. Okay, so find the derivative of the following functions using the first principle. S squared, 2s squared plus 4x, 3x cubed plus 4s squared plus x. Okay, so that is for assignment. Let me see, try test. So try test 1. So try test 1 or first test under a study or in our study of calculus. You have to find the derivative of the following function using the first principle. S squared, that is for I. 2s squared plus 4s I. 3s cubed plus 4s squared plus x. I. So that is that. Then question 2. So let's do question 2. Question 1 and let's say question 2. Find the derivative. Find the derivative of the following. So s cubed plus 4 3x exponent 5 plus 4x exponent 3 plus 6x exponent 2. I. 18x exponent 2 plus 6. So you have to find the derivative of this function. If y is equal to y is equal. So this one, you are not limited, so you can use any other ways or any other method or approach or procedure apart from the first principle. For this one, you have been limited to use the first principle, but for this one, you are free to use any method or procedures of which you think will be easy for you to find the answer. Thank you very much for learning with Ultimate Series.
Adding.